Hi, I'm Micah Nagel. I'm one of the engineers here at Defense Unicorns working on UDS Core. Today I'm excited to be providing a walkthrough and a quick demo of Istio Ambient Mode on UDS Core and what that means for you. So by way of a quick refresher on what UDS Core is, UDS Core is a secure runtime platform. UDS Core runs on top of Kubernetes and provides a number of services often required for controlled environments, such as logging, monitoring, SSO, and for today, most importantly, service mesh provided by Istio. We also include an operator that's powered by Pepper that automates integration with these services for your own applications. If you're interested in reading more about UDS Core, we have a documentation website hosted at uds.defenseunicorns.com where we run through configuration, how to deploy, and some tutorials to get you started. Our code is also open source, hosted on GitHub under the Defense Unicorns organization at UDS-Core. So to dive into Istio's ambient mode, some of the key benefits are lower resource requirements, reduced request latency, and simplified operations. You can see here on the page some of the example metrics that we've pulled for a 5-node cluster running on a cloud provider. And as you can see, we saw about a 29% decrease in CPU usage, 15% decrease in memory usage, a drastic 64% decrease in request latency, as well as a 13% decrease in deploy time. So these are all pretty great benefits regardless of your environment, including in the cloud, but especially exciting for us as we look to expand our edge capabilities. Now we'll switch over and look at a local dev deployment that I have and start to poke at some of the differences of Sidecar and Ambient Mode. So we'll start by looking at UDS Core of the past. This is a UDS Core version that's deployed entirely using sidecars. So if we log in here to the UDS UI with our Doug user, we'll be able to pull up a resource usage dashboard. This dashboard provides a snapshot of the cluster's resource usage, specifically memory and CPU. And we'll see here that memory usage is sitting around and a little bit above 8 gigabytes, and CPU usage hovers around a single core. Keep in mind this is a local, small, single node dev cluster. However, this provides a decent metric for us to compare ambient mode to. Now, as a refresher on what this looks like from the application side, we'll pull up the workloads and pods and take a look at auth service here. Now, auth service shows us running 3 containers. The first one that we want to look at is the Istio init container. This container runs at startup and is responsible for setting up the proxy redirection. The second container to be aware of is the Istio proxy. This is the traditional sidecar. It's an Envoy proxy that runs alongside your application and handles all traffic going to and from your application. And then the third container, of course, is our application itself, auth service. So this is something to keep in mind with Sidecar Mode. Every pod in your cluster will be running these 3 or more containers depending on the size of your application. So if we were to look at the rest of this list, we'd see that same thing across all of them. That's where a lot of the operational complexity can come in with these sidecar containers. You're responsible for injecting them, adding the sidecar when you install, as well as keeping them up to date. Now, our UDS operator traditionally has handled some of that complexity, but with ambient mode, a lot of that goes away. So we'll switch over now to a cluster running Istio ambient mode and take a look at these same views. So now I have deployed the latest release of UDS Core. In this release, all core services are running in Istio's ambient mode. So if we log in once again to the UDS UI as our Doug user, the first thing to note is that all of those same core services are available and ready. So with the switch to ambient mode, we didn't change what is provided by core. If we pull up resource usage once again, if you recall in sidecar mode, we were seeing around 8 gigabytes of memory used and around 1 full CPU core used. In ambient mode here, we see around 6.8 gigabytes of memory usage and around half of a CPU core. So that's a pretty significant reduction on the CPU side. On the memory side, we're seeing about that same 15% reduction that I showed in the example metrics previously. Now to look at how this compares from a workload perspective, we'll pull up our pods. Looking at that same auth service pod deployed now in ambient mode, we'll see that it only has the single application container running. So previously, you may recall Istio init and Istio proxy were two other containers added to this pod. In ambient mode, those two functions are both replaced by daemon sets. So the first daemon set we want to look at here is the Istio CNI daemon set. Istio CNI and the CNI plugin are responsible for the same function that IstioNet previously was. They handle setting up traffic redirection. So if you're wondering where that function went to, Istio CNI and its CNI plugin are now responsible for setting up that same traffic redirection and proxying. Then the Istio proxy, which was that Envoy sidecar, if you remember, that handled the actual traffic flow, handling all ingress and egress with the pod. That is now replaced by ztunnel. Ztunnel, again, is a daemon set, so it's a node level proxy. And the ztunnel pod on a given node handles traffic for all pods on that node. This proxy notably only handles layer 4 traffic. So if you need restrictions, authorization policies, for example, at layer 7, you'll also need a waypoint proxy. A waypoint proxy is a similar proxy to the sidecar. It's running Envoy. However, it sits outside of your application pod. It'll sit at the namespace level or at the service level and can be used to operate on layer 7 attributes. So we can also quickly look here at the logs, and if we pull up those ztunnel logs, we'll see that ztunnel is indeed handling all of the traffic for our node. So we'll see here as the logs flow by, we'll see some of the noisiest things in our cluster, mainly Loki and Prometheus you'll see in these logs. So this shows us that all of that traffic is being proxied through ztunnel. Finally, I just want to touch quickly on how we actually made this transition in UDS Core. You may recall that one of the core components is the UDS operator. This is a Kubernetes operator that manages the integrations with the rest of the stack, including service mesh. The main way to integrate a given application into the core stack is through a package custom resource. I'm displaying here all of the package CRs in my cluster, and if we take a look at the YAML for the auth service package custom resource, we can see a number of configuration items to include a service mesh mode. This service mesh mode can be set to either ambient or sidecar, and the operator will manage the complexity of upgrading or switching your application between the two modes to include changing namespace labels, adding or removing the sidecar as necessary, and ensuring a secure setup through network policies and authorization policies. All of the core packages here in my deployment have been switched to that ambient mode. However, this is also available for you in your end user application. So if you're integrating with the UDS Core stack and using a package CR, you can also set this service mesh mode to sidecar or ambient and see the differences for yourself. I hope this video was informative. Thanks for checking it out, and we'll see you in the next one.